Okay, so I've got a bullet, okay, fired into a block, then that block basically slides on a cart, okay? I want to figure out what the final velocity of everything, once everything is kind of settled down, everything's moving at the same speed, okay? And I also want to figure out the new position of the block on the cart. So let's take, the final velocity first. So basically I'm going to think about this in 3 steps, right? I've got the bullet coming in, bullet and block stick together, that's state 2, and then all 3 are, that slides to a new position and they come to, a constant velocity at state 3. Okay? So what I know is that whole process, if I take them all together, okay, I can say that my momentum is conserved from state 1 up to state 3 for the entire situation, right? Bullet and block hit each other, well, that's an internal impulse. Block slides on cart, well, if I take the cart and the block together, then, that's all internal. So that whole process of bullet colliding, block sliding, right? When all's said and done, if I take the system as a whole, all of that stuff is internal impulses. So momentum will be conserved, okay? So what I have is 0.028 mass of the bullet times 550 for the velocity, okay? And what that equals is all of those masses added together. So 0.028 plus the 5 kilogram block plus the 4 kilogram cart times the total velocity at that point, right? So I know the entire, for that entire process, the momentum is conserved. Okay, because all of those forces are internal if I take the system as a whole, right? So from that, I can find that V3 equals 1.71 meters per second. Now, to find out how far this guy slides, okay, now I need to break it up. I need to find the velocity of the block and the bullet right after the bullet embeds in that, before it starts sliding. Okay? But again, for those two combined, that's an internal situation in that the momentum is conserved, not 3 to 2 this time, right? Because the impulses are all internal, right? That impulse of the bullet hitting the block is an internal system. So I can find the velocity of these two before it starts interacting at all with the cart, okay? So with this one, I've got the same initial momentum of the mass of the bullet times its enormous initial velocity. Now my mass is just the bullet and the block, right? So it's just the 28 grams plus the 5 kilograms, right? This is before it starts interacting with the cart at all. And I now know that the velocity of the block with the bullet embedded in it, as it starts sliding onto the cart is going to be 3.06 meters per second. Okay, so now that I know that, now I can figure out how far it slides. And again, when I use distances and velocities, I'm going to use work energy, right? So I'm going to have my initial kinetic energy, or I should say the kinetic energy at state 2, plus all of the work done from 2 to 3 equals my final kinetic energy. Now, here's the thing, is I know my initial and final kinetic energies, right? Because I found V2, I already know V3 from the first part of the problem, right? So initially my kinetic energy is just the bullet and the block, right? Massed together. Well, we'll just do it this way. I'll call this 5.028. That's the mass of those two combined, plus its velocity, which is 3.06 squared, which we just found. That's the initial kinetic energy. Okay. Now the work done again is going to be friction. That's the friction between the cart and the block, right? Okay. And again, friction always opposes motion. It's always doing negative work, so I go negative. Okay. And from this, what I'm going to do is, again, I know my coefficient of friction is 0.5. Okay, and that's going to be times the normal force, which is going to be the 5.028 mass times the gravity, right? So that's the weight of the block, right, which is the normal force times the friction force. And again, that's going to be times the distance that it travels, right? That I'm trying to find. Because again, work is force through a distance, right? So I find the friction force times the distance that it travels, right? And of course that's going to be negative because friction opposes that motion, okay? And what that's going to equal is the final total kinetic energy, which again, we already know because it's 1/2 times the total mass, which is 9.028 this time because now the cart is moving as well, okay, times 1.71 squared, okay? And then from this I can find that S equals 0.42. So again, with these problems, just break them up into pieces. Some pieces are going to be impulse momentum, others are going to be work energy. You just need to figure out if it's, anytime you've got a collision, you can get rid of that collision by taking the system together and momentum would be conserved, okay? Use that to find velocities, and then from that you can back out, the work being done and just break it up into pieces.